So this is a recording for the 6.9 warm-up and practice from our notes packet. So let's get started with how we're going to practice writing some equations of parallel and perpendicular lines with the quadrilateral classifications that we did yesterday, or from 6.8. And so we're starting with seeing it just says classify it as precisely as possible, and then we're going to kind of take a couple extra steps to practice writing some equations, since that's what we did from 6.5 and 6.6. So when I see this diagram, it probably looks more like a rectangle or a parallelogram, and it will only be a rectangle if you can show that it has 4 right angles. Now, a lot of people want to just say, yeah, it's a rectangle, but if you don't actually support that with your algebraic work and your explanation, then really you cannot just assume that that's what it is. That's why it says show work to justify your answer. So let's go ahead and check the slopes. And when a diagram is provided, I do prefer to just use rise over run like this instead of like using the slope formula 4 times. You can do that though. So like from A to B, I'll write here, the M, which is slope of segment AB, goes up 1 and right 4. So this is 1 and right 4. That would mean the slope is 1/4. And then you can find the slope of the next segment, so we could do BC, of segment BC. So again, you're counting, I'll do it inside here. So going down quite a bit, let's count that, and then right 2 it looks like. So it's down 4, 8. So -8 is how far I went down, and then I went right 2. Okay, so if you go down 8 and right 2, that comes out to a -4. And then you do the same thing for the next 2 slopes. You'll quickly be able to see, hopefully, that the sides that are next to each other are opposite reciprocal here, or that the opposite sides are parallel. So again, we have another 1/4 for CD. You don't have to draw all of them in if you can kind of just look at it quickly and see what it is. So segment CD was 1/4, and finally AD is that last one, and that's going to be, again, down 8 and right 2. Okay, so you do have to write all 4 of those slopes to make sure that that's like your form of work to show that that's what I'm finding. Now, we don't actually have to find the distances because nowhere is it saying that you need to find the perimeter or the area or anything like that. If it does, though, we would have to find some of the distances. Well, it is going to do it down at the bottom for part C, but we'll do that when we get there. So for your explanation, you can say that quadrilateral ABCD, that was the name of it, is a rectangle because we were able to show, because the slopes of the adjacent sides or consecutive sides, the slopes of the adjacent sides, that means the sides that are next to each other, are opposite reciprocal. Reciprocals of each other, one another. And that's enough to say then that there's perpendicular lines that are formed. So the adjacent sides form perpendicular, and you can put the symbol or spell it out, perpendicular lines forming 4 right angles. Okay, and then since the last sentence I usually will write will be like what it is from the yellow sheet. If quadrilateral has 4 right angles, then rectangle. And you don't have to write complete sentences for every little part of it, but just enough that we get the understanding of what the shape is and how you were able to explain it. So please do explain it well, especially when we get to the test. Okay, number 2 talks about writing equations to represent these 2 segments for BC and for DC. And so I wrote out the coordinates for myself just so it would make it easy to find the equations. They are up at the top with the graph, but here are all of the coordinates. So for just B and C, because and D are the ones that we're working with here. We don't really need to mention A right now. So B was -1, 4, C is 1, -4, and -3, -5 for D. Okay, so then in order to write the equations, I need their slope. So I have the slope from above, right? For segment BC, it was -4. And the slope of segment DC separately, we don't have to do them simultaneously, but I already have those, so I might as well just write down the slopes. Now let's find one equation at a time. So for the slope, I have -4. I need to find the y-intercept. So I can use either B or C to help me find that. I'll just go ahead and use point B. So I would do 4 equals -4 for my slope. -1 is my x value here. This is x, this is y. And then plus B. And I'm solving for B. So I keep going here. And let's see what we get. 4 plus B equals 4. And then once you subtract 4, you're going to get 0. That means the equation for BC, or I should say segment BC, is y equals -4x. That's it. There's no equation, there's no y-intercept on that one. For this one, let's see what happens. You have to use either D or C. Again, I'll just pick C in this case, but it does not matter which one you choose. We have -4 equals, then we have the m, which is 1/4. 1 is the x value plus B. Again, I'm using this, x and y. Then we'd get 1/4 and subtract it to the other side. And we find out that B is, either if you want to write it as an improper fraction, it would be -17/4, or you could write it as a mixed fraction. So my final answer here for line DC is y equals, the m was 1/4 x, and then the slope, or the y-intercept I found was -17/4. Those are the two equations. Okay, so we found both equations for number 2. Finally, it says, can you find the area? In order to find the area of the polygon, which is, it's a rectangle, area formula of a rectangle is just length times width. So I need to know both the short side and the long side's distance or length. So I have to use the distance formula now, or I could just use Pythagorean theorem to find, let's say, AB. I need its distance. And then I also need segment, one of the ones that are next to it, so I could do like BC, for example. And once I find both of those in simplified radical form, I'm going to write the exact area here, because that's the way we've been practicing it even on the quiz, and then we'll go ahead and write down what our final answer is. So for the distance formula here, or for Pythagorean theorem, I'm just going to do Pythagorean theorem because I already have the triangle kind of already drawn in here. 1 squared plus 4 squared. And you would square root it. So this would be 16 plus 1, which is 17. That's what we get for the length of segment AB. For BC, it was 8 squared, -8 squared, and it was a +2 squared. So that would be 64 plus 4, which comes out to 68. And that can be simplified further into square root of 4 and 17. So this would become 2 root 17. Okay, and then once we're at this point, we're ready to start multiplying now to find our area. So this would be square root of 17 times 2 root 17, length times width, or whichever order you do them in. When you multiply those together, you can just use your calculator, but the idea is when you when you multiply two of the same exact square roots, you just end up with just the number inside, which is 17. So this is technically going to be like 2 times 17, which is 34, and since the units were not provided, we write u squared. That is the final answer. You can use your calculator to put that in to see what it comes out to. Okay, so that's it for the warm-up, and then let's go to the next page to continue this practice, and we'll see how far we get. And if anything is not in the video, then you can always check Canvas. This is all on Canvas for the answer keys. Okay, so it says 2 friends see a sketch of a quadrilateral, PQRS, then the vertices are given. One friend says that the quadrilateral is a parallelogram but not a rectangle. The other friend says that the quadrilateral is a rectangle. Which one is correct and how do you know? So we would have to check slopes whenever we're trying to decide between is it a rectangle or not. The slopes are what make it different, because if we have opposite reciprocal slopes for the adjacent sides, then yes, it's going to be a rectangle. So I'm going to start with each of my, I'm going to pick 2 points at a time. So we'll just go in order here. PQ would be negative 4 minus 2, and I have to use a formula here because I don't have a diagram to work with. You can do a sketch though if that helps you. This comes out to negative 6 over 3, which is negative 2. That's the slope so far for PQ. The next one, I'll do the slope of segment QR. And this one would be negative 5 minus a negative 4, and positive 1 minus 3. This comes out to a negative 1 over a negative 2, which is really 1/2. And so yes, looking at just those two, it looks like these are going to be opposite. These are opposite reciprocals. Let's just double check that all of them are going to work. So we have RS for segment RS now. So this would be 1 minus a negative 5 and negative 2 minus 1. But remember, your slopes don't have to look exactly like mine, but we do have to get the same answer because y's are always on the top. So this would be 6 over negative 3 again, which is still negative 2. That makes sense so far. The opposite sides should be the same because they're parallel. And finally, P and S would be 2 minus 1 and negative, 0 minus a negative 2, which is really 0 plus 2. So this is 1/2 again. Since we see all their slopes, that the adjacent sides are opposite reciprocal. I'm not going to write too much for my reason because I just wrote kind of the same thing on the front when it was also a rectangle. This is quadrilateral PQRS is a rectangle because the slopes of the adjacent sides are opposite reciprocals of one another. And so therefore perpendicular lines or segments essentially, which forms 4 right angles. Kind of similar to the explanation on the front. And then if you again want the if-then statement from your yellow sheet, it says if quadrilateral has 4 right angles, then it's a rectangle. Okay, and so that's it for this one, kind of similar. Now the next few are just starting to think about what you would do to show how you would actually figure out which shape it is. So when the first one says quadrilateral ABCD is a square, you would say which of the following you would not want to do because it won't give you enough information. So let's read through it and let's see what it would do. The first one talks about the slopes of the diagonals are opposite reciprocals of one another. So if you remember, the slopes of a square do have, they are perpendicular. So yes, that would be true so far. Therefore, the diagonals are perpendicular. The diagonals are also equal in length, also true for a square, so that you could find the lengths to determine that they are congruent. And then because the diagonals are both perpendicular and congruent, then it would then be a square. So yeah, you would find the slopes and the distances to be able to determine. That part looks okay. But the next one says, I use the distance formula to find all the quadrilateral side lengths. And so they found that AB, BC, CD, and DA were all equal. That means that all the sides are congruent, so that's why it should be a square. But unfortunately, if you don't show both things, it could technically be a rhombus. You have to show 4 right angles and 4 sides congruent in order for it to be a square. So this one we could say could be a rhombus. And that's why I'm going to circle this. If you read through this last one, it just talks more about showing the slopes of the adjacent sides are opposite reciprocals so that you create those 4 right angles. And then also checking that the slopes are all the same. That would make it, couldn't be a rhombus, it would be a square, because it was kind of technically a rhombus and a rectangle in order for that to hold true. Same idea on the last one, but we're trying to show kite this time. So it says MNOP is a kite because MN is equal to NO, which are like the consecutive sides. OP is equal to PM, so the consecutive sides are congruent. Now that part is right, but we don't know if there's a lot of other quadrilaterals that also have this true for them. So that's why this is actually, there's just not enough information to prove that this would work. So we could write, for a reason, other quadrilaterals have consecutive sides congruent, similar to like a rhombus or a square, because then technically all of the sides are congruent, not just a kite. So you need to show more that specifically the opposite sides are not congruent, or you could show about the diagonals and so on. So the middle one does do that. It talks about the adjacent sides being equal, but the opposite sides not being, so that would be enough to show that. Or talking about the diagonals having opposite reciprocal slopes so that the diagonals are perpendicular, and then also showing that the opposite sides are not parallel, not the same, so that they can't be parallel either. Okay, and then we go to the last page here, and we have classifying, again, just based on what you see. So draw some diagrams. It really helps to go through this, and I'll go ahead and do this part kind of quickly, just so that we can wrap up the video. In quadrilateral ABCD, so just draw any kind of four-sided shape for now. We don't know what shape it is yet. It tells us AD is congruent to BC. Whoops, I did the wrong tick mark. And then AB is congruent to AB is congruent to CD, which is across from it, and it also tells us about the diagonals. AC is congruent to AD. This would make this a rectangle. Now it does say to justify, I'm not going to write my justification, but I'll just kind of walk through it, that in a quadrilateral that has two pairs of opposite sides congruent, that makes it a parallelogram first of all. Then because the diagonals are congruent, that would make this a rectangle. Now you might say, well, what about it not being a square? We don't know that, since it didn't specify that all four sides are the same, it cannot be a square. And so the only one that has diagonals, only parallelogram that has diagonals that are congruent is a rectangle. Same thing on the next one. This time we have D, E, F, G. Oops, this is E and this is F and G. This time it tells us DG is parallel to EF, and also DG is congruent to EF. And so you're trying to figure out what this is. This is on your yellow sheet. There's actually a way to classify this, that there's enough information to show that this is a parallelogram when it has even just the same pair that's both parallel and congruent. And so we didn't spend too much time on this in Unit 5, but that is also on there. And finally, the last few here, quadrilateral math. So here's math, M-A-T-H. MA is congruent to AT this time, and MT, which is the diagonal, is perpendicular to the other diagonal. So not only do we have consecutive sides the same, but also the diagonals are perpendicular. So now we have a couple of different options. It could technically be a square, because it follows the criteria of the two consecutive sides. The other two would be in addition, because they all have to. And then it could also be a rhombus, though, because we don't know anything about the right angles, if it has right angles or not, for the angles at M, A, T, or H. And it could even be a kite. Actually, I'm going to write the word or, because technically it'd be one or any of those three, but we don't know which one, because all of these have the same classifications, which are consecutive sides congruent and diagonals that are perpendicular. And so we need more information to really narrow it down between one of those. And finally, the last one is QUIZ, and we have QU is congruent to UI, which is congruent to IZ, and ZQ. So because we know all four sides are congruent, this would be a rhombus. And you might say, well, why not a square? We would need to know four right angles in order for it to definitely be a square, in addition to the four congruent sides. All right, so that's it for the practice. Tomorrow we will or 6.10, we will pick up with a little bit more with these quadrilaterals and classifying them, and then we'll get ready for the quiz soon.